Okay, let's go ahead and get going here. We're looking at explore number 3 of biomes. This would be 1.4 of the living earth, 1.4.3. Why don't you make sure you write that in the left section of your margin notes there. Make sure you put down the date and draw your template out here. The essential question: what are the characteristics of Earth's aquatic biomes? Um, if you recall from Explore number 2, our notes were all about what are the factors that determine Earth's aquatic biomes. So we're going to build on that, and we're going to talk about the characteristics of that now. Okay, so pause your video and write down what you know. Okay, hopefully you took a moment to pause your video and write down what you knew. Let's start with Roman numeral 1, freshwater biomes. We're familiar with that here in the Salinas Valley Grainfield area. We've got freshwater biomes. We got the Salinas River, for example, right? So you can divide freshwater biomes into moving and standing water. Moving water are things like rivers and streams. We have the Arroyo Seco River nearby that flows into the Salinas River. Right, those are moving bodies of water. Before you become a river, you usually are going to be fed by smaller streams, what we call tributaries. You also have standing water. These are what we call your ponds, lakes. You have temporary pools, things that might not be full of water all year round. We don't have many freshwater swamps, and those tend to be elsewhere. We do have some freshwater wetlands closer to the Bakersfield area. There's a bunch of migratory bird preserves where you have freshwater wetlands. Surprisingly, glaciers can be considered in this category of freshwater biomes. They are frozen, freshwater, but they are moving very slowly. And you do find some organisms in there, usually more of the bacterial type, maybe even the algae type. There's some kind of odd things there. Letter C, talking about river systems. And we're just trying to scroll here on the left-hand side to stay with us, keep this parallel. River systems often start small. You can have a spring coming up from the ground. You can have small streams that develop that are fed from rainfall or from maybe small bodies of water, small lakes. As they flow down, because of gravity, they tend to increase in size. So rivers can be divided into zones, and the zones are really based on where they are between the source, where they start, and usually where they end, which is the sea. So we have your source zone. These are your what we call your headwaters of a river. These are where your mountain lakes and springs are. The water, when they start up high like this, the substrates are usually rocky, not dirt, but rock. The waters are cold. They're usually clear. They're flowing pretty quickly. You tend to see rapid water movement, waterfalls. Because of all that disturbance, the water tends to be well oxygenated. It is poor in nutrients because it's just running over ground. There's really not a lot of life in the way of plants and animals in there, so it tends to be poor in nutrients. The organisms that do live here are going to tend to be hiding under rocks, or they are adapted to be able to keep their position in that fast moving water. If you're a fisher person, somebody likes to fish, you definitely need to make sure you drop your fishing lure Now, you wouldn't even be using a lure. You would be trying to catch fish under the rocks or be looking for them where they seem to be able to keep themselves in position. The next zone is your transition zone. Uh, Imagine yourself moving down an elevation, down a mountain. The water starts to slow down in speed. The water gets a little warmer. You start to see suspended matter, more dissolved nutrients. Sediment starts to develop in there, and then sediment develops on the riverbed. Okay. And as you move down further, closer to the ocean, you could think about this like the Salinas River. The Salinas River, we might be talking about a floodplain zone. These are bigger, they're muddier, they tend to have more nutrients. The channels are a little wider, the currents is a little slower. You start to see plants growing in the water and on the embankments. Sometimes the river is green because of phytoplankton, and you start to see a greater variety of fish living here. So, if you like to fish, you really wouldn't want to be fishing up high in the Arroyo Seco, Big Sur, Ventana area where the rivers are flowing really fast. You're probably better suited to catching fish where the river is flowing a little slower, it's muddier, a little greener, more fish. Okay, so let's talk about standing water now. We got your lakes and your ponds, any body of water that is surrounded by land usually qualifies as a lake or a pond. The communities that are going to develop here really depend on how deep those bodies of water are. It also depends on the size. If you get to really large lakes, like the Great Lakes over in Michigan, these tend to actually resemble oceans in their characteristics. So, and those get really quite big. Now, we also talk about vertical stratification, especially when you get to deep bodies of water. So when you have very deep lakes, we might talk about zones, and these zones are going to vary. They vary in the amount of oxygen, they vary in the temperature. We talk about thermoclines, we talk about the differences in light, and also the amount of nutrition that's available. So let's make sure we bring our text so it's close to us. Lakes and ponds. All right, I think we're about here. All right, so let's first talk about the areas that are, if you're talking about a lake or a pond, the areas closest to the shore. These are your littoral zones. They're well lit. You tend to see plants growing here. Some of the plants are rooted in the dirt underneath, some are floating. If you go a little further out in the lake, the water gets deeper. You have your limnetic zone. That's the zone that's closest to the surface. A lot of sunlight, high levels of oxygen, maybe a little warmer. If you go deeper, but still further away from the shore, but deeper, you can get into what's called the benthic zone, and this is the lake floor. Now we'll talk about the benthic zone also with oceans because that also refers to the ocean floor as well. Okay, usually your sediment is down here. Invertebrates, things like worms, bottom feeding fish that rely on detritus, eating dead material, you're going to find them here. Oxygen levels also tend to vary. Oxygen can enter the lake or the pond from the surface, right? Because that's the interface with the atmosphere. And if you have a lot of wave action, that can also really accelerate the oxygen um, dissolving from the atmosphere into the body of water. You have a lot of phytoplankton in there, algae in there, plants in there. Now, I've talked so far about how you can add levels of oxygen into these bodies of water. It is important to understand that oxygen can also be removed from these bodies of water. And that's usually through bacterial or fungal activity. As they eat dead material, they have to do that through a process of cellular respiration, and that requires oxygen. We see that also in dead zones at the river deltas, like where the Mississippi River enters into the Gulf of Mexico. Um, there often tends to be a lot of phosphates from farming that enters the river and accumulates when they enter into the oceans, making it very rich. A lot of algae grows there, but once the algae dies, um, then bacteria has to consume it. So it actually is kind of an odd way to look at it, but the bacteria actually suck up all the oxygen, and so you produce dead zones. So again, that's on the idea that oxygen can be removed from these uh, decomposers, right? So the removal of oxygen from water is called your biological oxygen demand. Okay. And some areas have a higher biological oxygen demand than others. Sorry about the dog. All right, so you have different kinds of lake types. Some lakes, I don't know if you've gone backpacking or hiking, but if you're in an alpine lake, very high in elevation, you'll see these pristine blue lakes. And these lakes often, uh, even though they're beautiful, they're clear, they're deep, they're blue, they're very cold, but they don't really have a lot of nutrients in there. And because there's not a lot of nutrients, it's a bad place to fish. You're not going to get a lot of fish up there. Okay. If you Another type of lake type besides the oligotrophic, which we just mentioned, is the eutrophic. Eu means good, trophic means eating or food. So eutrophic lakes tend to have more nutrients. They have high plant growth. They may appear a little greenish because you have more algal, plant, and phytoplankton presence there. And as always, there's always something in between. You also have what are called meso meaning medium or middle, central, mesotrophic, and these are lakes that lie somewhere in between the two. Okay. Well, we've talked about lakes. Let's talk about freshwater wetlands. Okay, these tend to be shallow. They support growth of aquatic plants. Um, like I said, east of us, as you head over to Fresno and Bakersfield, there are some wetland areas. You also have what are called marshes. These tend to be covered with water all year round, and they're dominated by emergent plants. You tend to see reeds and grasslands growing out of those. And then you also have swamps. Swamps tend to be dominated more by bushes and trees. Okay, think Florida, right? Where you have these like kind of alligators and bigger bushes and bigger trees there. And you also have bogs. Bogs are freshwater bodies. Now, bogs tend to be in colder areas. Think go up to Alaska or the Canadian tundra and taiga areas, and you'll find bogs. The plants you find up there are more spongy moss, and um, and they tend to be a little more acidic. The water up there. Okay, so notice that um, here on the left here, wetlands provide many services to humans. The term is called um, ecosystem services. And what kind of services do we get from these freshwater wetlands and marshes and swamps and bogs uh, and fens even? Well, they provide flood protection. The people in Louisiana and Mississippi are protected somewhat by these systems. They store water, and they also actually filtrate our water from pollutants. Fens is a less common term that you're going to hear, letter I. These are wetlands dominated by grass and sedge. They tend to be fed more by mineral-rich surface water or the groundwater, not so much from other sources. Okay, Roman numeral 2, we're moving from freshwater into marine, so think salt water. Even though we think of ocean waters as being very salty, they're only anywhere from 1 to 3% salt, or what we call dissolved solids. Phytoplankton, this is important. Letter A. Phytoplankton in the ocean produce more than, brace yourself, 50% of the oxygen you're breathing comes from these ocean phytoplankton. Not our tropical forests like the Amazon. It's the green stuff in the ocean. Okay, and conversely, they also absorb a lot of carbon dioxide. Now, when the ocean meets the land, we have special terms for this. Um, if you've been to the aquarium over in Monterey, uh, they they have a section that has to deal with the tidal zone, right? You know what I'm talking about, the intertidal zone. This is where the ocean meets the land. Not an easy place to live. I mean, if you need to be underwater all the time, you may not have you're going to be exposed to the air when you have low tide, right? So you have to have organisms that are adapted to these areas. There's constantly changing temperature. The salt water levels are constantly changing. Sometimes, if you got fresh rainfall, that's going to dilute the salinity and make it less salty. When you have high tide, it's going to be saltier. Um, you're exposed to the air, you're exposed to the water. So it's a challenging place to live in these interface areas. So organisms on the shore, then this sounds natural. They're going to be distributed based on their tolerance. If you can tolerate the salinity variation, you might be higher up in these intertidal zones. If you can tolerate the temperature fluctuations, you might be higher up in these zones. So, what are these zones? Well, your book actually just talks about the high tide zone, mid tide zone, and low tide zone. There's a splash zone up at the higher levels. High tide zones are going to be organisms that are submerged only at high tide. Otherwise, they're exposed. So they got to be highly adapted. Your mid-tide zone organisms, they can survive in small pools. If you've ever gone looking through the tidal pools, you'll notice that during low tide, you still have these little pools of water. These are what we call your mid-tide zone organisms. And then your low tide zone organisms are going to be the organisms that are still submerged even when you have low tide. And this is where you tend to find the most diverse populations of organisms. It's usually where you find the best. Uh, if you're looking for starfish and urchins and sea cucumbers and things like that, you're going to find them in these low tide zones. Now, not every shore has these zones like that. Sometimes you go out to areas like the Gulf of Mexico and it's just kind of muddy. And you can walk out for miles just to your ankle, knee depth. Really, you can walk forever out there. And so these don't have these high, mid, and low tide zones like we have here on the West Coast. Um, so the organisms here usually they bury themselves into the substrate. So even here in Morro Bay in California, we kind of see that where the tide can go out a little further out, and you find your starfish and things like that. These are things that bury themselves in the dirt, right? And sometimes we'll refer to areas where the tide goes out a long distance as intertidal marshes. That's a term, intertidal marshes. Okay, so continuing with our ocean discussion here. Um, what do you call the areas that are right off the shore in the ocean? We call them neritic zones. These are areas right off the continental shelf. Now you got to remember, think back to your Earth and space science. You know that there's continental plates, and you have continental crust and oceanic crust. Well, where the continental crust goes under the ocean, you can have these shelves. And that's what they're referring to as these continental shelves. They tend to be rich in nutrients. They're well illuminated. In tropical areas, if you get closer to the equatorial line, you'll see corals that are developing in those areas. Now, there's another zone called the pelagic zone or the pelagic zone, and this is getting into the deeper ocean. So if you go beyond the continental shelf, all of a sudden it'll drop off. The water gets very deep. And just like in lakes, the upper regions tend to get more light. So you're going to have more light in these areas as well. So you're going to see your phytoplankton. These are your drifting, remember, plant type organisms. They can't really swim themselves, so they're subject to the ocean currents. And you also have your animal based organisms that also can't swim. They just float with the currents, and these are called your zooplankton. If you go deep, just like a lake, you're going to come across your benthic zone, and that's getting close to the ocean floor, right where the ocean floor meets the ocean water. It's got a lot of high pressure, very high pressure. It's very cold, low temperatures, very dark. And if you get to the very deepest parts of the benthic zones, you get to what are called the abyssal zones. I don't know if you ever watched the movie The Abyss, but when I was growing up, I thought that was a pretty cool movie. Went to the very, very bottom of the ocean, the abyss. Um, a lot of a lot of weird creatures, highly adapted that live down there. These are the ones that bioluminesce. They have big teeth, big jaws, big stomachs, so they can swallow whole what they eat. Right, so that's down in the abyssal zone. Okay, so we talked about freshwater. We've talked about marine water. So, as you know, the water in between, where water from freshwater meets saltwater, we call those your estuaries or your estuarine zones. Estuaries are another kind of interesting place. You got to be highly adapted to live here. There's a lot of change always going on. Sometimes the water's got high salt levels, sometimes it has low salt levels. If you have a lot of rainfall, heavy winter rains, you get a lot of flow down that river. These estuaries become um, uh, low salinity. They develop a lot of fresh water. If you have high tide, then a lot of ocean water is pushing up into these estuaries, and so the salt water intrudes and the water becomes saltier, right? So not every organism, every animal can really handle that, or every plant. Animals and plants that are adapted to these areas are called euryhaline, as you can see highlighted there. Eu meaning good, haline meaning salt. And well, I think that we talked about everything there. That was quite a bit of material. So good job if you hung in all the way to the end there. And make sure you go through all of this, okay? Why don't you go ahead and write yourself a summary paragraph right now, and we'll talk to you soon, okay? Bye bye.